first cannons, also called mouths of fire, appeared in the 14th century. Made from strips of wrought iron assembled by hand, it wasn't rare for them to explode on firing. So, for a long time, people were reluctant to load these weapons onto ships. In the 15th century, cannon manufacturing methods improved. Made from a new bronze alloy, they became safer and more precise. They were installed in large numbers on sailing ships with high freeboard, or height above the water. Unlike galleys, they had no oars, and so had space for artillery weapons along their sides. So began a new era, that of sailing ships and their powerful artillery, which were to dominate the seas for the next 3 centuries and change the art of war. The history of these warships began in the late Middle Ages.
It started in the late 15th century and early 16th century with the appearance of the galleon, which was very archaic. It was quite a big, rounded, bulging ship with castles fore and aft.
The wide decks could take a large number of artillery weapons. However, their weight raised the ship's center of gravity and destabilized it. The solution was found in the late 15th century with a simple but revolutionary idea: the invention of the gunport.
The gunport was a rectangle of wood, which the shipwrights cut into the hull. When the gunport was closed, you couldn't distinguish it from the rest of the hull. Then in battle you raised this sort of shutter. You pushed the barrel into the hole, loaded the cannonball, and fired.
The introduction of the gunport was fundamental. If the cannons had stayed on the decks, it would have been impossible to increase their weight because of the ship's stability. If you put heavy weights high up, obviously the ship will have a tendency to list or even to sink. Placing the cannons below decks lowered the center of gravity, and therefore you could increase the weight, and also the caliber of the cannons.
The caliber of the artillery progressed rapidly. In 1638, the largest cannon was a 12-pounder. It fired a cannonball weighing 6 kilos. 7 years later, the 18-pounder cannon appeared. And in 1682, the most powerful piece of artillery was made with a caliber of 36 pounds. This 3-meter-long colossus fired a cannonball weighing 18 kilos over 300 meters.
The cannon alone weighed 3.5 tons. With all the equipment, it was closer to 6 or 7 tons. So it was huge, and that was why 15 men were needed to service each 36-pounder.
Cannons of the same caliber were installed in batteries. The lightest were positioned on the upper deck and the heaviest on the lower deck. Each battery was made up of 2 broadsides, one on either side. At the end of the 17th century, the largest ships had up to 3 batteries, giving them the impressive number of 100 cannons.
As these ships were more stable than galleys, the cannons were more effective. They could fire further and with more precision. They could fire further because they were higher in the water, so that's ballistics. And they could have more precision because as the platform was more stable, they could be aimed more accurately.
Combat at sea was changing. They weren't trying to board each other's ships anymore. They weren't trying to get close to each other. On the contrary, they were keeping at a distance and fighting in what would become the famous line of battle, which developed in the late 17th century and would continue in all its glory until the end of the 18th century.
From 1664, boarding, with its risky outcome, gave place to the tactic known as line of battle.
You had about 40 or 50 ships divided into 3 groups: the vanguard, the battle corps, and the rear guard, which had to fight the enemy in the same way. And the 2 squadrons sailed past each other, then turned around and did the same in the other direction. So you had battles lasting 10 or even 12 hours.
You weren't seeking to systematically destroy the others. You wanted them to retreat, showing that you were the strongest. You occupied that area, and you were sovereign in that particular place.
This war of intimidation involved the most powerfully armed ships, the ships of the line. In the vanguard were the ships with 3 decks and more than 80 cannons. In the middle, the ships with 50 to 68 cannons, and in the rear, those with fewer than 50 cannons.
In the line of battle, you obviously tried to have the ships following each other, with the same nautical performance and approximately the same firepower, so you didn't create a weakness in the line. You need to try to imagine a sort of great fortification in which you systematically placed cannons of the same power.
For the larger ships of the line, cannons and cannonballs combined exceeded 300 tons. That significant weight meant that the design of the ships had to be revised.
If you place a lot of artillery in the hull, what do you have to do? You have to make the hull longer, or else you won't have enough space for the cannons, and you won't have enough space to operate the cannons. So you make it longer. But as you lengthen the ship, you also need to make it wider, because if you make it too long, it will become fragile and will have poor nautical qualities. So you have to increase its width. If you do that, you also have to increase the size of the masts. So you need to find larger timber with a greater diameter.
The French Navy, like its foreign competitors, wanted to construct the best warship. Today, warships go through a long development phase. Armament, speed and maneuverability are considered in response to the needs of modern warfare.
On a des logiciels extrêmement puissants qui
We have very powerful software which allows us to design the ship in 3 dimensions and very quickly to be able to integrate all the equipment and systems on board the ship.
à bord de ce navire.
Steel hull, propulsion system, electrical and computing networks are built in at the shipyards. These ships are meticulously assembled using gigantic cranes 104 meters tall, equivalent to a 35-story building, and gantry cranes capable of lifting 300 tons or 15 trucks at the same time. In the 17th century, warships were constructed by hand. It all started with the keel, the backbone of the ship.
Constructing a warship was extremely complicated. You had to create a hull, starting with a keel, onto which you join wooden frames, like the ribs connected to one's sternum.
These ribs or frames gave the hull its shape. It was much less slender than that of the galley, because the builders were looking less for the best movement through the water than the efficient distribution of the artillery's significant weight. In order to erect an impenetrable barrier, the distance between each frame was smaller than the width of a cannonball.
Onto this wooden structure, they nailed the planking on the outside, so very long planks of wood which were placed along the hull from the keel to the upper deck. Inside, there was more strengthening, an inner skin, if you like, called the ceiling, so it was reinforced by planks of wood on the inside.
Frames, planking and ceiling formed a hull, which could be up to a meter thick. That's why it was called the wall. This wall was pierced for the gun ports. They were arranged at an equal distance, 2.4 meters apart. And so as not to weaken the hull, they were arranged in a checkerboard pattern. The position of the gun ports was of crucial importance, as shown by the tragic fate of the Vasa. Disaster struck during the Swedish ship's maiden voyage on the 10th of August, 1628.
The boat was very unstable. The gun ports were too low down, and the water very rapidly flooded into the hull, making it sink very quickly.
That day, the 1,000 sailors on board lost their lives in the port of Stockholm. The sinking of the Vasa highlighted the importance of the height of battery.
This is the distance between the waterline and the bottom of the lower battery gun port. There must be a certain distance, or else the ship will take on water through the gun ports and will end up sinking. So this height of battery can't be too small, but it can't be too big either, or the stability of the ship will be affected. It will lack stability. It won't have a good attitude in the water.
After a year in the shipyard, the hull was finished and launched. The final stage could begin, the fitting out of the ship. This wasn't about positioning the artillery, but rather installing the masts, sails, and rigging. The masts reached 30 meters high, the equivalent of a 10-story building. To help with their installation, the shipbuilders used a sort of crane called a masting machine.
They had what was called a masting machine, which was about 70 meters tall. It was made up of big masts tied together with ropes, which were made to lift very heavy loads and to install the lower sections of the masts in the ships in the vertical position. Then they added the upper sections of the masts, which were ringed with iron, and then they could add all the sails.
The surface area of the sails determined the ship's speed, a decisive element during battles at sea.
As ships became bigger and heavier, as they carried more artillery, they needed more efficient sails because the sails were the engine. So they increased the surface area to make the ship go faster. You could divide the sails into two groups. The big rectangular or trapezium-shaped sails were mainly used for propulsion, for speed, and the smaller triangular or square sails were used more for maneuvering the ship.
In full sail, these heavily armed ships could reach 9 knots, or 17 kilometers per hour. That was 30% faster than galleys. It took about 100 craftsmen a year and a half to build these Lords of the Sea. Each ship was unique because the master shipbuilders guarded their trade secrets jealously.
The extraordinary thing about these wooden ships was that the builders handed down their technical expertise through 6 or 7 generations.
The designers of the ships stuck to the tried and tested methods. It's like recipes in cooking. Once you have the right balance, you don't change it. There's the know-how, the knack, all of that.
Whilst the recipes most often produced efficient ships, they sometimes made ships that were incapable of putting to sea. Given their cost, the Navy couldn't afford a failure like the Vasa.
The number of people it took between the master shipbuilders, the shipbuilders, shipwrights, the cannon manufacturers, the foundry workers, the sailmakers, everything you need on a ship, from planking to hemp, cannons and armaments. It was quite extraordinary.
A ship cost £1 million in the late 18th century, which was equivalent to 300 kilograms of gold.
For the time, this extraordinary cost forced France to draw up construction standards that would guarantee the excellence of ships. Arsenals like Toulon, Brest, Rochefort or Lorient played an essential role. They developed new technical solutions and trained the best shipbuilders using extremely detailed models.
These big models, usually 1 to 10 scale, were almost a kind of simulator. You stood around them. You were there to learn. You were there also to see the effect of the wind on the sails. They were instructing the master shipbuilders. So they were a real 3D training school.
In 1765, France founded the School of Maritime Engineering. It trained the future engineers who would replace the old shipbuilders. These men of science used the new mathematics and insisted on drawings. It was the birth of modern naval architecture.
In the 18th century, times had changed. Certain inefficient ships had been abandoned for good, and the 74-gun ship of the line had been perfected. It was the battleship par excellence.
Its name was the Téméraire. It was the first warship built according to a naval architectural plan. The plan was the work of two men, Jean-Charles de Borda and Jacques-Noël Sanet.
Borda was the academic, the mathematician, the scholar, and Sanet was the highly skilled and competent engineer who made his career following the training route of the time as a shipbuilding engineer.
Together, they optimized the 74 gunship of the line, conceived 40 years earlier. They found the best compromise between firepower and nautical qualities.
It was the result of a lot of research to obtain a ship that was capable of functioning as well as possible at sea while fulfilling its military role as an artillery platform.
The ship's dimensions were impressive. 57 meters long, 15 meters wide. Its tallest mast was 85 meters high.
When you imagine a ship moored at a quay level with a person, with its banks of sails, it was pretty impressive. If you placed the 74-gun ship of the line with all its sails unfurled in front of the Arc de Triomphe, the arch would be completely hidden, completely invisible.
It weighed 2,950 tons. This giant was powered by more than 40 sails, with a total surface area of 2,600 square meters, or 6 basketball courts. This powerful propulsion allowed it to reach the unheard-of speed of 11 knots, or 20 kilometers per hour. The ship also had exceptional maneuverability, a crucial advantage in battle.
These nautical qualities were desirable because in battle, changing tack was a very complex operation. Tacking took half an hour of maneuvers, assuming that the enemy wasn't firing at you from all directions. So the desire for maneuverability was essential in terms of war.
The ship could change tack in just 15 minutes. That was half the time of its opponents. This prowess was made possible by the addition of one element on the mizzen sail, located at the stern of the ship, the boom.
Gradually, this sail was perfected. The bottom of the sail was attached to a piece of wood called a boom, which kept the sail more rigid. And that was great, because it meant you could trim the sail very accurately and adjust it by a few degrees, more or less.
Fast and maneuverable, the ship was powerfully armed. Its 74 guns were arranged in 2 batteries. In the lower battery, there were 28 36-pounder guns. In the upper battery, 30 18-pounders, and on the upper deck, 16 8-pounders. In the hold, it carried 4,400 cannonballs and 22 tons of gunpowder, enough to last 6 months. This ship was a formidable artillery platform. Sanet and Borda's ship of the line was the centerpiece of the French Navy.
The ship was built according to blueprints which standardized the model. That meant they could develop construction according to pre-established, standardized models, with a ship that would be identical.
In 1 century, around 100 ships were produced in the shipyards. This success inspired foreign navies which sought to copy them.
In the 18th century, industrial espionage was rife. There were British engineers who tried to come to Toulon to spy, and also to Rochefort. This espionage also happened when an enemy ship was captured, so technical knowledge and know-how circulated widely.
These 74 gunships of the line and their variations, the 80-gun and the 118-gun, showed their power by exhibiting their artillery. Today, the stakes are very different. 21st century warships seek to be stealthy.
The object of stealth isn't to make the ship invisible. That's impossible. It's to make it less visible, so that its radar imprint on an enemy's screen looks like a small ship or another ship, rather than a threatening, high-tonnage warship.
On enemy radar screens, the battleship appears no bigger than a fishing boat. This achievement is made possible by the shape of the hull, which is able to attenuate radar waves.
The main means of detecting a ship at sea is radar. The radar emits electromagnetic waves, which will touch the metal sides of the frigate, and this wave goes back to the radar, and the enemy radar gets an indication of direction and distance. The frigate has superstructures on the incline to avoid reflecting the wave, and also completely flat sides, because any cavity represents a sort of cage that amplifies the radar signal and re-emits it with more power, so you can be detected from much further away. So really, thanks to its shape, a Frem today that weighs 6,000 tons is seen as a boat of a few hundred tons that's hardly visible on an enemy radar.
Stealth is a key advantage when ships confront each other without seeing each other. It allows you to strike the adversary before being spotted. But when the battle is a deadly head-to-head, the advantage will be with the one that has the greatest firepower.